Okay, this is a final live lecture for this semester. So we have switched for this final exam week. We won't have a Friday and Saturday session. We did those on Monday and Tuesday. So you can watch the recordings from those. So there'll be information about how to access the recordings. But I am speaking right now, so hopefully you can hear me. And if not, there's information on the screen about where to go and what to do with that. So I'm going to go ahead and move on then. You can ask questions in the chat or by raising your hand and turning on your microphone. So feel free to ask questions if there's anything specific you want to look at. Otherwise, I have predetermined, I have a list of questions to go over. So we'll come back to that, but this is where you'll go to watch the recordings if you want to watch the recordings from Monday or Tuesday, or from today, or from any of the past live lectures throughout the course. So we'll come back to that later. For now, what I want then. So I've been asked to look at a couple of questions from the homework. So we'll start with that, and then I'll look at my other questions. So question number 3 on the homework. So this is looking at graphing a quadratic function, and it's given in standard form. So the first thing you need to do for that is to come up with because it's asking to use transformations, you need like the vertex form rather than the standard form. And so the easiest way to get that is to know the shortcut. So for the vertex is your HK, H is always going to be negative B over 2A from the standard form. Now that's not on your formula sheet, but if you remember that it's part of the quadratic formula, which is on the formula sheet, it's the quadratic formula without the square root piece of it. So if you can remember that, then you don't have to memorize, but it's negative B over 2A. So in this case, that's going to be negative 6 over 2 times 1, which is negative 6 over 2 is negative 3. And then the K, the y coordinate of the vertex is going to be the function. You just plug in whatever that negative B over 2A result is. So you don't have to have a separate thing to memorize for the y coordinate. You just know once you have the x coordinate of the vertex, then you can plug that in and find the y coordinate. So in this case, negative 3 squared plus 6 times negative 3 plus 8. So that's 9 minus 18 plus 8, and that is negative 1. So we have the point negative 3, negative 1 for the vertex. Now, this is going to be graphed using transformation. So the vertex corresponds to the horizontal shift and the vertical shift. And then the only other piece you need for the transformations is A. And so that's going to be the same, like that's from standard form or from vertex form. That corresponds to then any vertical stretch or compression. And then if it's negative, then there would be a vertical flip, which would be a reflection across the x-axis. So when we go to the graphing tool, you're going to start out by choosing, it already has the parabola, so it says click the graph. So we can click anywhere on the graph and it'll put the default just the x squared graph. And then we use this box. So the vertical stretch compression even says that's going to be A. That's just 1 because A is 1. Then I have the vertical shift, which is K. That's the y coordinate of the vertex. So that's minus 1. The horizontal shift, And I'll say the horizontal stretch of compression, you should never be putting anything there. You just leave that as 1. So even like they have A on both of those, but you're going to do that just on the vertical. The horizontal shift is H, which is the X coordinate of the vertex. So that's -3. And there's no reflection, and I drew this point wrong. So I plotted -1, -3, and it would actually be where this has ended up, which is -3, -1 for the vertex. And then you see the graph, and notice from this form, C is always going to be the y-intercept. So I can confirm you have that y-intercept happening at C, so that matches up. The x-intercepts you can see there at -4 and -2 correspond to this factors into x plus 4 and x plus 2. So you have all these pieces that fit together when it's graphed correctly. That, hopefully if it's graphed incorrectly, you can recognize that those don't match up. But the main thing is the -b/2a for the x coordinate of the vertex, which is the horizontal shift. Plug that into the function to find the y coordinate, which is the vertical shift, and that should get you there. Just make sure that so all right, and then number 47 was also requested. So 47. So solving this logarithmic equation. So solving logarithmic equations, you want to get either a log of something equal to something. So that form that then you can rewrite into exponential form. So you'd have, let me do this slightly differently. So rather than using letters, because then I think you get fixated on the letters, it's all about the location. So we have log of something at the base, and then you have something in the log, and then it's equal to something on the other side. So you would rewrite that in exponent form. You can think of it as you're applying the base on each side to cancel out the log. So you end up with the base of the log to the power of what it was equal to whatever was inside the log. So now you've undone the log. The other possibility is you get log of a base of one thing equal to log of the same base of another thing. And then the logs just cancel each other out and you get them undone. What we have here to start with is we have multiple logs on one side of the equation and then a number on the other side. So it doesn't quite match either of these. I can't undo the log unless I have either one log equal to another log with nothing outside of the logs, or one log equal to a number with nothing else outside the log. So I need to combine these. So I'm going to combine these logs into a single logarithm. There's actually a couple ways I could do this. So one, I can, so I'm going to combine these. So I take the 2 outside the log, anything outside the log, I want inside other than what's on the other side of the equation. So the power rule I'm applying here. So we have these rules on the formula sheet, and I'm going to mess up my notes here. So I'm just going to so you have these rules. So I have the power rule, and with these you can go either direction. So I'm starting with something being multiplied by a log, and the power rule says that that multiple can go and become a power on what's inside of the log. So the 2 is becoming the power. So we have log base 8 of x minus 3 squared plus log base 8 of 16. And the equals 2 is fine. I'm just going to leave that there because I'm just trying to combine this left side into a single logarithm. All right, so then I have the product rule here where I have 2 logs being added together. And if I do that, equals, from left to right, that tells me that that's the same thing as the single logarithm with that base, with those things being multiplied together. So the x minus 3 squared times 16. So I get, if I simplify this a little bit, log base 8 of 16 times x minus 3 squared equals 2. And now I can undo the log. So if I apply a base 8 on each side, so I'm using this property that says then the 8 to the log base 8 of whatever is inside the log, that those basically cancel out. I just have the 16 times x minus 3 squared equals 8 squared. So I applied the base on both sides. The relationship between log and exponent where you rewrite, so whatever letters you're using, like log base e of x, log base b of x equals y, corresponding to b to the y equals x, that relationship isn't on the formula sheet. So if you want to use that, you can kind of, if you can think of it as you're undoing the log with the base, then that is on the formula sheet. So you're applying the base to both sides. So at this point now, it's not logs anymore. We can solve it. So this is 16 times x minus 3 squared equals 8 squared is 64. Then I'm going to divide both sides by 16. And so I have x minus 3 squared equals 4. X minus 3 squared is x squared minus 6x plus 9. And then move the 4 over to get a quadratic equal to 0, factor that back out, and this is going to be I think a minus 5 and a minus 1 will work. Those add up to -6, multiply to get positive 5. So I get 5 and 1. But then the last thing you need to check with log equations is we do have limits on the domain. We can't take the log of a negative number. So 5 minus 3, I can plug that in and it's fine. 1 minus 3 would come out negative, so that doesn't work. That's what we call an extraneous solution. I didn't do any incorrect algebra to get there. It's not like a wrong answer, but it's still not actually included in the solution set. Now, another way I could do this is I could simplify the log base 8 of 16. So log base 8 of 16 is saying what power of 8 is equal to 16. And they are both, even though 16 isn't a power of 8 directly, a whole number, but they're both powers of 2. So we have 2 cubed and then 2 to the 4th. So then I can say, well, what do I multiply by 3 to get 4? And that would be 4/3. So I could have this as log of log base 8 of x minus 3 squared equals 2 minus 4/3, which is 2/3. And so I would have then, that would just get rid of the 16 a little differently. It's still going to work out the same. That's probably actually messier to work with. You have to recognize that you could evaluate log base 8 of 16, and then you have to know how to evaluate, and then you have to deal with fractions. So I think it was easier to not approach it that way. But then the other thing with this question is it's asking you first to just rewrite the given equation without logarithms. So they want you to give some form of the equation at the point where you've gotten rid of the logarithms. So let's see if it'll accept just this 16 times x minus 3 squared equals 8 squared. So just that was the first part of the process where I had gotten rid of the logs and it accepted that. Let me see now if it would, I think it would accept really any form. So here, like I would have log base 6 of x minus 2 squared times 9 is 2, so 9x minus 2 squared equals 6 squared. So if I went ahead and went to the step where I have x minus 2 squared equals 4. Okay, it doesn't want you to go 2 versus that's farther than I wanted to go. I have 36 and the 9 here. Does it accept? I'm just kind of so okay, so it's okay with going ahead and doing the 6 squared, but it didn't want the division step to happen. So you just want to look at kind of once you've gotten to far enough in the process that you've undone the log, that step. I will say though, I don't think the actual exam is going to have any of those where you have to like give your part of your process that way. You do want to write your process out on your paper though, that's going to be turned in to your proctor or submitted to your instructor. So if you do end up with a wrong answer, they can look back and see, depending on your instructor, if they can see that you did part of the process correctly. Even if you end up with the wrong answer, they might give you partial credit. But yeah, just make sure on the solution set that you do check with those logarithms to not include extraneous solutions also. All right, so anything else about those 2 questions or any other questions from the homework or the review quiz or the practice test that either of you want to look at before I jump into the set of questions that I had?
I'm okay. I'm just here trying to get all the information I can before this final day for tomorrow. Thank you.
All right, sounds like a plan. All right, well, I'm going to go ahead then. Find my So I'm just, we have a set of questions that we're kind of looking at between the 3 review sessions. So some of them that were covered Monday and Tuesday, I'm putting kind of farther back on my list. So again, you can, if you attend those sessions or watch those recordings, you'll get more questions. But so this is just the one I'm starting with, which is you have these multiple logarithms that you are being asked to combine into a single logarithm. So this is using both the power rule and the quotient rule here. But both of them in, or sorry, not the quotient, but the product rule. Potentially the quotient rule though, if you had a subtraction. But in all cases, you're kind of starting with the right side and going to the left side. So when you have these properties, they work both directions. So that equals, it's not that you're having to always start at the left and turn it into the right side. We can start with the right side and turn it into the left side also. So in this case, and I would recommend doing it one step at a time, where you first kind of apply the reverse power rule to get those exponents. So we have the 4 log base 2 of u, the 4 becomes a power on the u. And then the 5 log base 2 of v, the 5 becomes a power on the v. And so we have log base 2 of u to the 4th plus log base 2 of v to the 5th. So we want to not have anything outside of this single logarithm, and the first step is just moving those powers inside. And then the plus, those 2 logs being added together, can be combined into a single log of the same base with, because of this being added, then those inputs get multiplied. Technically, we should probably put parentheses because logarithm comes before multiplication in the order of operations. So log base 2 u to the 4th times v to the 5th. So just apply those properties. Okay, so then next one I'm going to look at is a quadratic type question. So we're also let's look at the domain and range. And where it is increasing and decreasing. So, okay, so we have the function x squared minus 4x. And the first question I asked, is it opening up or down? So that's just based on A. So up would be a positive A, down would be negative A. So in this case, A is 1, B is -4, and C is 0. So positive A, it's opening upward. Then what are the coordinates of the vertex? So that's going to be the x coordinate is going to be -b over 2a. And so in this case, that is -4 over 2 times 1. So 4 over 2, which is 2. So we're going to have an ordered pair here. It says type an ordered pair. So the first coordinate is 2, and then plugging into the function f of 2 is 2 squared minus 4 times 2, which is 4 minus 8, which is -4. So 2, -4, so I can plot and see where this would be on the graph. Here at 2, -4. The axis of symmetry is always going to be, you're typing in an equation, it's a vertical line, it's x equal to the x coordinate of the vertex. So the axis of symmetry is always going to be that x equals the x coordinate of the vertex. For the x-intercepts, you always are going to set the function equal to 0. So x squared minus 4x equals 0. This type where you don't, or where C is 0, sometimes throws people off, but so you need to factor it. This is factoring out an x, and so it's x times x minus 4. And make sure you get then both of those results, 0 and 4 for x. So, and you can see then as I'm plotting this, the x-intercepts, if there are x-intercepts, they're always going to be equally distant to where the vertex is exactly halfway in between them. So if you're coming up with results where that's not happening, then you know something's wrong. Now, when it just asks for the x-intercept specifically, so it didn't ask for intercepts in general, it specifically asked the x-intercept. So it knows that what you tell it is x values, then it doesn't want the ordered pairs, it just wants those values listed. So you could list them in either order, 0 and 4 or 4 and 0. It just says type an integer or decimal. It doesn't say ordered pairs, so it doesn't want ordered pairs. If you gave the ordered pairs 0, 0 and 4, 0, MATLAB it's going to count that incorrect. So that's the x-intercepts. Then the y-intercept. The y-intercept, when you have this standard form, C is the y-intercept. The y-intercept is also always f of 0. So you plug in 0 into the function. And then the other thing is, if you have an x-intercept of 0, you have to have that has to be the y-intercept also. So various clues to say the y-intercept is 0. Did you have a question there, Tish?
I am so sorry about that. I just wanted, before we went past this, how do you know for sure to put the parentheses or not? Is it'll say just type the number or ordered pair to put the parentheses, like just the numbers with the comma, or put the parentheses with
Yeah, so you would only do parentheses if it says type an ordered pair, or if it's asking for an interval that might involve parentheses.
And put it in notation.
But yeah, I'm pretty sure if it wants an ordered pair, it'll always say underneath there type an ordered pair. And if it just says type an integer, like, yeah, here it says type an integer. Sometimes it'll say type an integer or a fraction or that type of thing.
Now No
But
print.
yeah, the other way is, again, if it asks for just the x-intercepts or just the y-intercepts, it's always going to want just the x values or the y values. If it asks, what are the intercepts, right? And then if you just typed in the 0 and the 4, there wouldn't be any way to tell if those were x values or y values. So then you'd have to have the ordered pairs for it to be clear.
Right.
So when it just says what are the intercepts, it wants the order pairs, but then it will, again, it'll say type order pairs. So you have kind of a couple of clues there. It's not completely, sometimes it feels like it's just random. There is a logic to it.
There was a
And I
couple.
would say, I can't
Did I
speak
have-
for all of your instructors. For me, as an instructor, if you put the order pairs and it didn't need to be the order pairs, to me, that's not wrong. Like it's
Right, there was
still
a couple
like
times
that is the x-intercept and y-intercept. Versus if it should be the order pairs and you just give the numbers, that's a problem because now I don't know if that's an x value or a y value.
Right, I had the numbers right. I just put the parentheses on the outside of it, and it counted the whole problem or the answer
Right.
wrong because the
Right.
parentheses.
Math lab will count that wrong depending on your instructor may give you, and I would at least check, like tell your instructor, like, hey, I had the right numbers, but it
Right.
I gave the order pair on the exam. They're probably going to at least give partial credit. Homework for me, like homework, because you can redo it until you get it right.
Yeah.
Then I don't usually give partial credit. But if it's like the quiz or the test or something where you can't just go back and fix it, then I'm like, well, you had the right answer. You just didn't give it in the form that it wanted.
We pay attention to what is asked, then we know the parentheses if it says the ordered pair or interval notation or whatever.
Right.
Don't just
Now-
ask for the integer.
Yeah.
Yeah. Okay. Thank you.
Now, the other thing to watch out for, because like if you had the 0 and 4 and you put parentheses around those two numbers, so like if you just gave 4, 0 for this answer, I can't tell for sure if that means you're saying that the 4 and the 0 that are two separate points, like 4 or 0 would be one of, that'll be the order pair for one of the x-intercepts.
But it's a different plot if it's
But
0.
if you want to say the 4 and the 0 as two separate points, putting those in parentheses would not be correct. So when you're listing individual separate values, like you shouldn't put. So even
Alright.
like if I have solutions of an equation, there's like 4 and 0 are the solutions versus solutions of an inequality where it's like parentheses 0, 4, that's then representing not just the 0 and the 4, but everything in between. So, then it means different things. So yeah, you kind of get used to in like pre-algebra or, when you're learning like order of operations and you have parentheses where sometimes, having the parentheses there or not there doesn't especially matter. When we start using the parentheses to indicate an order pair or an interval, then it starts mattering. Like if they're there when they shouldn't be, it's a problem versus like if I have, let's say I'm saying 2 plus 3 plus 5, and I can put parentheses or not put parentheses, and it doesn't hurt to have the parentheses, right? So you're kind of used to that, I think, versus when the parentheses mean it's an order pair. So 0, 4 as two x values versus 0, 4 in parentheses would mean that's an x value and a y value, or it might mean that that's, again, an interval where it's including everything in between. So 0, 4 would graph as just those two distinct values. The interval 0, 4 would be everything in between those two values. So, it's meaning different things by having the parentheses there or not there. So mathematicians apparently just love like having the most efficient way possible to express what they mean, but then if you don't know that it matters, they're like, oh, you left out the parentheses, now it's a totally different thing.
You think you got it figured out. Wait, no,
So-
just kidding here. You got to do this too. And that math lab is very picky. I've learned.
Yeah.
Very picky.
And depending what you're doing in life, if you're spending a lot of time trying to communicate with computers, like you have to get used to, they are very picky. And if you put a space where they don't want a space, they're going to be like, computers are very smart in some ways and not very smart in other ways. So math lab at least isn't too picky, I think, about spaces, but something's like, you say 3.1 1, 2 instead of when it was looking for 3.1, and it's going to be like, that's a completely different thing. I have no idea what you're talking about. Or, if you're solving an equation and you put, x equals 2 and it just wants the 2, it's going to be like, I don't know what this x equals is. I have no idea what you're talking about. Can't help you.
Right.
So,
It took me
yeah.
forever to figure out the IN was like on the next page. It looked like a cursive L.
Oh,
You know,
yeah. Yeah.
it took me forever to figure
yeah,
out.
it's not IN, it's LN.
Well, LN, I'm sorry, but it looks
Yeah.
like a lowercase I, but it's like it looks like a lowercase L.
Yeah, and that's the problem. That's a problem with the font, really, because if you had a font that had a little bit of a, made it look like an L instead of an I. But yeah, so it's for natural logarithm, and then it's in opposite order because it was in Latin or something that has things in different order. So logarithm, natural, whatever. So, but the is just for logarithm. So yeah, but yeah, because MATLAB isn't going by what it looks like, it's going by the code that has an L and I are completely different codes, even if they end up looking the same. So
so just watch out for the pay attention to the fine print, more or less.
yeah.
Okay.
And again, depending on your instructor, if it's just details like that you're getting wrong, hopefully they're giving you at least some partial credit, so you're not getting, the computer is going to count it fully wrong, but your instructor is going to be like, yeah, that was mostly correct, and hopefully, give you points accordingly.
Okay.
So,
all right, thank you so much.
Yeah. All right. So the domain and range. So the domain for quadratic function is always all real numbers. The domain is the x values that will work in the function, and for a quadratic, no matter what number you plug in there, it's not going to break anything. With domain, what you want to watch out for is, are you dividing by something with x in it anywhere, because you can't divide by 0, or are you taking the square root or some other even root of something with x in it, because we can't take square roots of negatives. But as long as you're just multiplying the x's by each other, by numbers, adding, all that, there's not anything that we can't multiply, add, subtract, etc. So the domain is always all real numbers for quadratics. The range is going to be from the vertex, and since this opens upward, from the vertex upward, starting with square brackets at the y coordinate of the vertex, and then going up to infinity. So the range, you always want to think from the bottom of the graph to the top. So if it was going downward, you would start with the negative infinity and then go up and stop at the top. So it always goes kind of least to greatest, bottom to top, left to right, not the other way around. So that's the main thing to watch for the domain and range. The intervals where it's increasing and decreasing. So that's where we're going to be looking at intervals of x values. So looking, so it switches at the vertex. Before the vertex, all of this part thinking left to right, the graph is coming from wherever way up higher, it's decreasing that whole time, even though you only see that part of it. But all the way from negative infinity all the way until it gets to the vertex at 2 is where it stops. And then from 2 onto infinity, it's increasing. But we're looking, again, with the increasing and decreasing, you want to think left to right on the graph. We're not, when we say 2 to infinity, that's not because it's going up towards infinity vertically. It's because we're going to infinity in the x, and then from the negative infinity on the y. And so we're taking that graph, looking at the pieces of the graph where it's increasing or decreasing, and looking at what are the x values where this is happening. So that's the main thing to watch with the increasing and decreasing. And same thing, even when you get to the have the function, the other types of graphs where you're asked about increasing and decreasing and constant, you always want to think left to right, what are the x values where this behavior is happening. So that's that question. I think all the pieces of that. So next I'm going to look at, all right, this question that has the log graphing and kind of the graph of the log versus the exponent. So I was trying to do the snip just to have space to write the answer. I think there's space on this. And this way I can scroll down and not lose. So, all right. So we have log of x plus 5 minus 3. So when you're looking at a log function, in fact, I'm going to make this bigger. So a little bit here. All right. So for the domain, the thing to keep in mind again, so with domain in general, you have, these are the rules you have now. So you have, if there's something on the denominators, you have whatever's happening on top, you have an expression on the denominator, then you need that to not equal 0. So that's where you'll have the not equals. If you have stuff inside of a square root, then you need whatever's inside the square root to be greater than or equal to 0. You could take the square root of 0. You can take the square root of positive values. You can't take the square root of negative numbers. So that's where you'd have the greater than or equal to or less than or equal to. Then with logarithms, we can't, so the log has to be greater than 0. We can't take the log of 0 or of a negative number. And that's to do with what you're putting into the log is representing the result of taking the power of a positive number. So when I take any power of a positive number, I'm still always going to get a positive number. I'm not going to get 0. I'm not going to get a negative number. So when we reverse the process and take the log, what goes into it has to be a positive number. So for the domain, when we're looking at the domain of a log, the -3 out there is not going to affect the domain at all. The only thing that matters is the x plus 5 has to be greater than 0. So that means x has to be greater than -5. In interval notation, that's going to be parentheses -5 to infinity. But on the graph, we can think about when I'm looking at the x-axis, from -5, that's the only part of the graph where there's going to be a graph. So if I look at these possible graphs, I have this one here that looks like it starts at -5 and goes on from there. So that one seems good. This next one, B here, seems to start at +5. And so, we don't have this part of the graph. So that looks like the wrong domain. And same thing on C. D again has that domain starting at -5. The vertical asymptote. So a log graph will always have a vertical asymptote, and it's going to be x equal to whatever the endpoint of the domain is. So we have this part of the graph that looks vertical, but it has to be, for this example, at -5. So B and C have +5. That also corresponds to the plus. So if I take log x and then change the x to x plus 5, that's a horizontal shift to the left 5 units. So going back to section 3.5 transformations, we've shifted the log graph left 5 units. So the basic log graph, you have the vertical piece and you have a curve, and then it's not quite a horizontal piece, but it kind of flattens out. The turning point happening around the origin. So if we shift it to the left 5 units, then that vertical piece, is shifted and is 5 units to the right of the origin. The -3 here is shifting this graph down 3, and that's going to show affect where that turning point happens. So we're looking for that turning point to happen below the x-axis. And so that's going to correspond to this graph here. We have that shift down versus this graph A has been shifted up. So that makes that incorrect. So the graph is based on recognizing those shifts, left, down, up, right, but the left or right and up or down. The left or right, I think, is easier to determine based on calculating what's the domain, what's the vertical asymptote. Then you don't have to remember is the plus left or right, is the minus left or right. You find the domain and the asymptote will determine that. The range for a log is always all real numbers. Now, the log and exponent are inverses of each other. So inverses switch x and y and everything to do with x and y. So the domain becomes the range for the exponent. The graph gets reflected relative to the line y equals x. So kind of the y and the x switch places or flip. So we're going to have a graph that is a reflection. So it's going to have, instead of a vertical piece, a horizontal piece. And we'll look a little bit more at the graph, but the range then of the log is going to become the domain of the exponent. And then the vertical asymptote of the log, vertical is going to switch to horizontal for the exponent. And the x is going to change to y. And so for the exponent, we're going to have a graph that has a domain of all real numbers. It's going to have a range starting from -5 to infinity with the horizontal asymptote at -5. So we get that much at least just from thinking about the inverse of the log. To actually find the inverse function, there's two approaches. So we have, let's see, log x plus 5 minus 3. So one approach is to switch x and y and solve for y. So we have then x equals log of y plus 5 minus 3. So to solve that, I have to isolate the log. So then I have log of y plus 5 equals x plus 3. Then I have to apply the correct base to both sides to undo the log. Since there's no base written, it's base 10. So y plus 5 equals 10 to the x plus 3, and then subtracting 5. So 10 to the x plus 3 minus 5. The other way to think about this, as long as the x only shows up once in the whole thing, is I can look at what's happening to x. So I list those. The first thing happening to an x is add 5. Then the second thing, what happens to that result is it gets a log applied, and that's a base 10 log. And then the third thing happening is subtracting 3. So the inverse is going to undo those things in reverse order. If you think of the function as taking an x, and if you think of like wrapping a present, it's wrapping in these multiple layers of wrapping paper packaging. The inverse is going to unwrap it, but it has to start with the outer layer first. So it's going to unwrap that last thing that got added on, and then unwrap the next thing. and finally get back to the X that you started with. So we're going to undo these things in reverse order. So first undoing the subtraction of 5. So undoing step 3 by adding 3. So we have the X plus 3. Then the reverse of step 2, undoing the base 10 log, is a base 10 exponent. So there's the 10 to the X plus 3. And then undoing the first thing, the adding 5, by subtracting 5. So notice getting the same result either way. It's just a matter of which process makes the most sense to you to think about that. So 10 to the X plus 3 minus 5. The domain and range, again, are going to correspond to the range. So of the log, the range of the log was all real numbers. The domain of the exponent is all real numbers. The range of the exponent is going to correspond to the domain of the log. That was -5 to infinity. So -5 to infinity here for the range. So we're going from -5 up. So that narrows the graph down to A and B. And then we have to think about, should it be to the right or to the left? So there I can look at a couple things. I can look at the X plus 3 and recognize that should be a shift to the left 3. So we want this graph. I can also think about what is it going to look like to take the graph that I chose for the log and to reflect that across y equals x. So we have this graph here that has a vertical piece and then a turning point like this, and we reflect it across y equals x. So we have the horizontal piece here, and then the turning point, kind of opposite there then to the right. And why is that? Oh, because I'm looking at A, we said was not right. That's why I was pointing out this was the correct graph. So we had let's try that again with the correct graph for the log. That was the, all right, so we had this down here and turning point reflecting across the y equals x. We're going to have then the turning point still somewhere down to the left. So that makes this one the correct graph. If you're not sure, like you could try plugging in a value for x and see, like if you want to see like and you don't have to be super detailed, but I can tell like just figuring out positive or negative. So like if I'm trying to pick between A and B, if I plug in even like 0 for x, then I can tell on this graph it's going to be negative. And then on this graph, when I get to 0, it's going to be like a super large positive. So I just plug in, 10 to the 0 plus 3 minus 5. And that would be 10 cubed minus 5. That's 1,000 minus 5. So I can tell like it needs to be the one where it's way up positive, not where it's negative. So if you're not sure between two graphs, if you can find an x value where you can tell at that x value, again, the easiest thing is going to be that you can easily tell one is going to be positive and one's going to be negative at that x value. Then by evaluating there, you can tell which one has to be the correct graph. So, so that's that question, and let's see if I have time for one more anyway. All right, so this one here, what rate of interest compounded annually is required to double an investment in 21 years? So the first thing, we're looking at interest, we're looking at compounded annually. And you have these on the formula sheet, you have the interest, so we have compound interest and continuous interest. Continuous interest, if you see the word continuous, then you use that one. Anything else, you're going to use the compound interest. Compounded annually means one time per year. So the other thing, when you have that equation, so P times 1 plus R over N to the NT versus PE to the RT. When you see the E, the E goes in continuous, and again, that's even labeled on the formula sheet. So if you see continuous, you need to do that one. But here you need to know N is the number of times compounded each year. And then, you know, in both cases, R is the annual interest rate in decimal form, T is the number of years. But this, we're looking for the rate of interest, so we're solving for R. And I did see your question there, and I can look at that one, yeah. So interest rate required to double an investment in 21 years. So we have T is 21, N is 1. We're doubling an investment, so A is 2 times P. So 2P equals P times 1 plus R over 1, the 1 times 21, plugging those in. And I'm not sure if you can clarify, are you asking any of these as in any of the ones I'm going over, or the ones I'm going over from this PDF that I'm looking at? You're going to have questions at least similar to these for sure on the final. The ones in the homework, I can't necessarily say 100% because obviously there's a lot more homework questions than there are exam questions.
Right, I was just wondering if we were going to have the ones like the number 12, I'll
look at that homework number 12 for sure.
Okay,
but I'll finish this one first, just so I'm not
absolutely.
stopping.
Thank you.
Yeah. All right, so just to simplify the log, I can divide both sides by P here, so I get 2, and then I'm going to simplify a little bit, so 1 plus R to the 21 power. Then I'm going to apply a 1 over 21 power to both sides to undo that power. So 1 plus R equals 2 to the 1 over 21 power. So you just have to put that into your calculator correctly. 2, and you might have a button that looks like X to the Y or X to like a square, or you might have a button that looks like carrots, that up arrow type symbol. If it looks like this and you don't have a exponent position, then you have to put parentheses around whatever's going into the power. So this comes out like that should be something bigger than 1. So yeah, this is 1.0. That again. 1.033 thing. So that's the 1 plus R. So I just need to subtract 1, and so we get just the 0.033, etc. And that's the decimal form. So multiply by 100 to actually get the percent form, and then rounding to 2 decimal places. So I don't round to 0.03. I round to after I've multiplied by 100. So I'm taking this result, subtracting 1 to get the actual rate, multiplying by 100 to get the percent form, and then rounding that result to 2 decimal places. So this would be 3.36%. So, all right, let's take a look at that number. Let's see, do I still have that up or has it? Yeah, okay. All right, number 12 on the homework. All right, so finding all the zeros. Okay. So finding all the zeros, the first thing to check for is, does it factor by grouping? When you're finding the zeros, especially if it's a cube, so you just have those 4 terms, you want to see, can it factor by grouping? So I look at the first 2 terms and I can factor out an x squared. And I'm left with 5x minus 1. And that's promising because that's what I have over here, 5x minus 1. So that'd be a plus 1. And so I end up with an x squared plus 1 times 5x minus 1. The x squared plus 1, then, if you know x squared plus something is never going to factor in the real numbers. So no zeros associated with that. The 5x minus 1, if I set that equal to 0, is going to be 5x equals 1. So x equals 1/5. Let's see, it says use integers or fractions for any rational number. So it does want the 1/5, not the decimal form. So we would have, yeah, 1/5. Now, okay, 7b. Well, that's a completely different thing then, isn't it? All right, sorry. You said 7b, I just didn't look at that.
I am so sorry. That was helpful. I'm so sorry.
Not a problem. Maybe that won't be helpful to somebody too. Just a reminder that if you had tried to do that one without factoring by grouping, it would have taken a lot longer. So worth mentioning. And let me find 7b. I think because that's past 2, I have to actually go. Actually, tell you what, because we're out of time, if you don't mind. No, you're not my class. I was gonna say I'll just go and look at your actual homework assignment, but you're not my student, so I can't do that.
Okay, I've got a meeting with my tutor. If you had time, that would be great. If not, then I
no, it's fine. I was gonna say I could stop the recording anyway and then look at your but I'll take a at least look at the question and see. But it might be helpful if, especially if you think it's a rounding thing, then that might be something to like that would be better for somebody to actually look at your specific question, your work, and your answers. But I'll still.
I understand the whole process of it. It's a word problem. It was the assignment that basically the whole 35 were word problems, more or less. Right. But you have to substitute the values they give you or the amount of money, what the numbers they give you. And I know which number to substitute this and that. It's just when it comes to the rounding part, I was getting the first part of it wrong because they asked two different, you know, like an A and B. And I mean, I had like the very first part of it right. I was just like a couple numbers off. I think it's, you know, probably going back to the elementary. So it's probably a matter. All right.
So yeah, and the thing with these is if you choose the wrong n value, so this is the p times 1 plus r over n to the nt, and then pe to the rt. If you choose the wrong value for n, you'll get an answer that's fairly close but not exact. The other thing is if you do any rounding partway through, so if you calculate the r divided by n, for example, and round that off, then you could end up with the wrong result. So it might be a calculator thing or a rounding too much too soon or using the wrong value for n. So like this is compounded monthly, then you'd use n equals 12. And so that would be p is 100, 6% means r is 0.06. And this is asking how long it'll be. So we're doing 1350 equals 1000 times 1 plus 0.06 over 12 to the 12t, solving that for t. So dividing both sides by 1000, 1.35. So you don't want to round, like if that didn't come out to something, you know, like if that was something You would keep the fraction form. You wouldn't round off a decimal there. Let's see, I'm gonna go ahead and do a log both sides. I'm just gonna pick, you could do a common log or a natural log. I'm just gonna do ln because that's one less letter to write. And I'm not doing any like calculations or simplifying that. I'm just going to do that after the fact. The reason I do the natural log at this point, that allows me to bring this down from the exponent position. So I have t times 12 ln 1 plus 0.06 over 12 equals ln of 1.35. So then I can divide. But again, anything that you're writing down and rounding off partway along the way is going to then potentially make your rounding be off at the end. So this calculator is a pain to do logs with, but hopefully you have a calculator that's a bit easier. But I would do like 1.35, so ln of 1.35 divided by, and I'm going to put parentheses. I'm just going to do this as all one big thing, 12 times, and then it's I'll put parentheses 1 plus 0.06 divided by 12. And on most calculators, you would do the ln first and then put what's going into the ln, but on this computer calculator, but so you should get something that looks something like this: ln of 1.35 divided by 12 times ln 1 plus 0.06 divided by 12. And so that comes out 5 point, let's see, what are we rounding to? 2 decimal places, so 5.01. And then for the compounded continuously, and you'll see that's going to be a much easier calculation. So that's going to be the A equals PE to the RT. A is 1350, P is 1000. E is E, R is 0.06. So I still divide both sides by 1000. So I have 1.35 equals E to the 0.06 T. Now when I do ln of both sides, it cancels out the E. So I have 0.06 T equals ln of 1.35 divided by the 0.06. So yeah, much less messy calculation. And that's where like it's tempting with that messy calculation to try and simplify things. And then you end up rounding things off, and it's going to make your end result just be a little bit off of what it should be. So here 1.35 ln of 1.35 divided by 0.06 comes out 5.00. So just a tiny bit difference. But if you used, something other than 12 for the, or if you, maybe if you had quarterly, so I don't know if they would necessarily always be monthly.
It was rounding. I see where it was. It was just in my rounding. I just did my rounding wrong because I did everything right as far as substitution. It was just my answer was like 8. The right answer was 8.13, and I put 8.10. So I just didn't round it right, evidently. It had to be
right,
in the
but
round.
if you were that far off, so like if it was 8.13 and you put 8.12, it might just be that we rounded incorrectly. If you got 8.10 versus 8.13, I would get like it that either you rounded something earlier on in your process, or it could be that you used like the wrong value for n somewhere in, like if you use
what I thought, because I think I did 4. I don't know why instead
so
of
if it's supposed to be
12,
compounded monthly and you did 4
right,
instead of 12, then that could make that little bit of difference.
Yeah, that's something I need to pay attention to too. I noticed that I believe I used the 4 as I'm looking over my notes because I had over 4. So I from the quarterly, I think I was still stuck on quarterly from the previous problem. But yes,
so
thank
like
you so much
if
for
I
going
do
over
the
that.
same one, if it was quarterly, just to show the it would probably make about that amount of difference if I did it with 4
numbers are a little bit different.
times. Yeah, but just as far as the relative amount of difference it'll make is going to be, going from monthly to quarterly. See, there's 5.04 versus 5.01.
Yeah.
So actually going from quarterly to monthly is going to make a little bit bigger difference than going from monthly to continuously.
Okay.
So yeah, that's probably what happened is if you used 4 instead of 12.
Yeah, when I was looking at my notes, I've got over 4 instead of 12 because I know she put over 12. So
Yeah.
I think maybe that
Yeah.
might have been first and could have been in my rounding too. So I'll just make sure I pay close attention to that when
Yeah.
I'm doing tomorrow. I thank you so much for that. I thank
Yep.
you so much.
That's another thing where depending on your specific instructor, if you write out your process, if you write down at steps and they can see, they might look at it and say, oh, you did the whole correct process other than you used 4 instead of 12, then they might give you partial credit. And I would hope they would give you some, but if you don't write anything down and you're off a little bit on these, it's like, well,
Don't leave them.
I can't tell how
Right.
wrong you were or how right you were. So, writing down the work can definitely make a difference for that.
All right. Thank you so much. I appreciate it.
All right. Good luck on your exam. Any other questions from anybody before I shut things down? You just came in. Did you have anything? Oh, and I didn't do the there's a feedback link for this week too, but I guess it'll be on the recording now anyway, to go there and do the feedback if you watch the recording. But I'm going to go ahead and stop the recording here.